All right, continuing with chapter 7, we're going to look at 3 variables. So systems with x, y, and z. So if we look at x, y, and z, we've got 3 dimensions. So your intersection could be a point or it could be a line. It all depends on how those different lines are going. Could be a plane. So a single solution, a line, or a whole plane. To solve these, you're going to use elimination. So if we look at these bottom 2, we can eliminate the z's right away by adding these together. So 2x plus x is 3x. Y plus y is 2y. Negative z plus positive z is 0. And 2 plus 2 is 4. So now that y is gone, or z is gone. So we need to get rid of a z from the other equation. So if we were to use the top one and the bottom one, we would have to multiply everything in this bottom one. Did I use the bottom? Yeah. Multiply everything in this bottom one by 3. Not 3, because we're trying to get rid of the z here. So if I want to get rid of the z, I got to multiply by 6. So it'd be 6x plus 6y plus 6z equals 12. And then we are going to subtract. So 3x minus 6x is negative 3x. 9y minus 6y is 3y. 6z minus 6z is 0. And 3 minus 12 is negative 9. Now we can eliminate the x. The 3's already matched, so we're going to add. 3x plus negative 3x is 0. 2y plus 3y is 5y. And 4 plus negative 9 is negative 5. Divide both sides by negative 5. And we have y equals negative 1. So it's just an extra step at the elimination on the bottom, or at the beginning. Now we solve this system the same way we did before. So since we know negative 1, we're going to plug that in for y and solve for x. So 3x minus 2 equals 4. 3x equals 6. X equals 2. So now we have an x and a y, so we can plug them in to here. So x is 2, y is negative 1, z we don't know. 2 plus negative 1 is 1. And then subtract 1 from both sides, z equals 1. So we should check those. It's always good to check. So 3 times 2 is 6. 9 times negative 1 is negative 1. 6 times 6 is 6. 12 minus 9 is 3. Works in the first equation. 2 times 2 is 4, because I substituted the x value. 4 minus 1 is 3. And 3 minus 1 is 2. So it works in all 3, which means our answer, our ordered triple, always goes x, y, z. So our answer is 2, negative 1, 1. Sometimes you only have 2 equations and 3 unknowns. Just means our answer is going to be a line. So if I wanted to do this, I could multiply everything on the top by 3. So we get 3x plus 6y plus 3z equals 12. The x's have the same sign, so we're going to subtract everything. Negative y minus 6y is negative 7y. Negative 4 minus negative 3 is negative 7z. And negative 9 minus 12 is negative 21. And we want to solve for one of the variables. So we know it's going to be infinite, but we can still pick an x, y, and z. So if we solve for z, we're going to add 7y to both sides. So we have negative 7z equals negative 21 plus 7y. And then we're going to divide everything by negative 7. So z, negative 21 divided by 7 is 3. 7 divided by 7, 1. Negative 7 is 3 minus y. So z is going to equal 3 minus y. So if we go back to our original equation here, we have x plus 2y plus z, but instead of z, I'm going to write 3 minus y. And now we're going to solve for x. So if I combine like terms, x plus y plus 3 equals 4. Subtract 3, we get x plus y equals 1. And then x equals 1 minus y. Now, our x is in terms of y. Our y is y. And our z is 3 minus y. So that's how we can write our answer. We could have here solved that one so it said y equals, and then solved the original one so that it said x equals and they were in terms of z. It's the same answer. It's fine. You just want to have your points with an equation or letters in for each point. Okay, here is another system. Let's see. This one already has one variable gone. So if I add z to both sides, y equals z minus 1. So now we can plug this into another equation. So x plus y. Is this what I just... No, this is a different one. But instead of y, I'm going to write z minus 1 and then minus z. So our y is in terms of z here. So I'm going to solve x in terms of z, maybe. See what we get. Z minus z is 0. So we end up with this. X, add 1 to both sides. X equals negative 1. So now we have a negative 1 and a y. And it's in terms of z. So let's see what we've got. Our x is negative 1. Our y is z minus 1. And our z is z. So there's our solution for that one. Okay, next. Oh, I did that there. Okay, 3 students buy different combinations of basketball tickets for their families. So the first student buys 1 senior ticket, 2 adult tickets, and 1 student ticket. So if we wrote that equation, it would be 1x plus 2y plus z, and they spent $39. The second ticket, 1 senior, 1 adult, 3 student tickets, should be $37. The third student is 2 senior, 3 adults, and 4 students for $77. If possible, find the answers. So we're just going to solve these. So let's see. What do I want to get rid of? Why don't we get rid of the x's? So I'm going to rewrite these here. X plus 2y plus z equals 39. X plus y plus 3z equals 37. And 2x plus 3y plus 4z equals 77. All right, so I'm going to eliminate the x's. 2y minus y is y. Z minus 3z is negative 2z. And 39 minus 37 is 2. Then if we do these, let's do the top and the bottom. So I have to multiply the top by 2. So 2, and then 2 times 2 is 4. Z times 2 is 2z, and 39 times 2 is 78. So if I subtract these, I get negative y plus 2z equals negative 1. And if I get rid of these y's, we end up with 0 equals 1. Well, that's never true, so there's no solution. We can stop there. It's always good to double check your math, but there's no solution, so we're done. There's no way that this works out. Okay, investment problems. So we're breaking something down into money. $2,000 is invested at 1%, 2%, and 2.5%. So it's broken up. So we know we're investing 3 different amounts of money for a total of $2,000. There's one equation. The amount invested at 2.5% is 6 times the amount invested at 1%. So if we call this XYZ, we know Z equals 6 times whatever X is by that second sentence. And then interest is 44. So 0.01 was our X, 0.02 was our y, and 0.025 was our z. And if we put that in, we got $44. So there are our equations. Well, let's see what I want to do here. Well, we know z equals 6x. So if here we do x plus y plus 6x equals 2,000, we have 7x plus y equals 2,000. So y equals 2,000 minus 7x. So we have something that z equals in terms of x and something that y equals in terms of x. So we can plug those into the original equation, or into the interest equation. So 0.01x, and then instead of y, we're going to do 2,000 minus 7x. And instead of z, we're going to do 6x. Now we only have one variable to deal with. So I'm going to distribute my 0.02, and I get 40 minus 0.14x. And then if I multiply this, I get 0.15x. Combine like terms, we get 0.02x plus 40 equals 44. Subtract 40 from both sides. X equals 200. So that means $200 went into the 1% interest. Well, if we go back to this equation here, z equals 6 times that. So z is going to be 6 times 200, which means z is $1,200. So the 2.5% was $1,200. And then if we go back to our original equation here, they all have to add up. So 200 plus y plus 1,200. Oh no, what happened? Plus 1,200 has to equal 2,000. So y plus 1,400 equals 2,000. Y has to equal 600. So the 2% was $600. So you're just using your sentences to make those equations and solve for the individual pieces. Animal feed, so this is something you're going to see, is made from corn, soybeans, and cottonseed. And this table shows you the protein, fat, and fiber content. They want to make a batch that has 22 units, 28 units, and 18 units of protein, fat, and fiber. So we're going to turn these into equations by just saying XYZ, 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 and the total's our answer. So now we have 3 equations. So if I rewrite those, we have 0.25x plus 0.4y plus 0.2z equals 22. 0.4x plus 0.2y plus 0.3z equals 28. 0.3x plus 0.2y plus 0.1z equals 18. All right, first thing I want to do, I'm going to multiply everything by 100 so we can get rid of these decimals. So if I did that, I have 25x plus 40x, or 40y, plus 20z equals 2,200. Then I have 40x plus 20y plus 30z equals 2,800. And 30x plus 20y plus 10z equals 1,800. So if I look at these, the bottom 2, the y's will cancel out. So I'm going to subtract everything, and I get 10x plus 20y equals 1,000. If I double the top, so 30 times 2 is 60, 20 times 2 is 40, 10 times 2 is 20, and 18 times 2 is 36. Now I can do the same thing on the top and get rid of the y's. So 60 minus 25 is 35. The y's cancel, the z's cancel, and 3,600 minus 2,200 is 1,400. Look at that. That one I managed to cancel out both. So 1,400 divided by 35 tells us that x equals 40. So now we can plug that into here. We have an x. So 400 plus 20y equals 1,000. Subtract 400, 20y equals 600. So that should be z, not a y. My bad. Z. So z equals 30. Now that we have those, we can plug them into one of the original equations. So 0.3 times 40 plus 0.2y plus 0.1 times 30 equals 18. So that gives us 1.2 and 3, I think. Let me just make sure I'm doing this right. 0.3 times 40 is 12. So let's do this again. 12. And 0.1 times 30 is 3. So if I subtract, we end up with 18 minus 3 minus 12, 3. Divide by 0.2, y equals 15. So if we go back to our table, we wanted corn was x, so 40 corn. Y was soybeans, so 15 soybeans. And 30 cottonseed. That's how you do that. So the table makes it really easy. You just add in your variables and solve. Now, what if we only cared about fiber and fat? So we only care about these bottom 2 rows. Well, we're going to do the same exact thing. We're just going to use 2 equations. So we have the fiber equation. Or I think this might be the fat one. And then we have the other equation. Okay, here we only have 1 decimal place, so I can multiply everything by 10. So 4x plus 2y plus 3z equals 280. 3x plus 2y plus z equals 180. If we subtract everything, we get x plus 2z equals 100. We already know we have 3 equations, or 3 variables and 2 equations, so we're just going to solve this for x. So x equals 100 minus 2z. So that's what we're going to put in our x. So now we need to solve for y. Let's do, I'm tired of decimals. So 3 times 100 minus 2z plus 2y plus z equals 180. So we want it to say y equals. So we get 300 minus 6z. So if we bring the 300 over, we have negative 5z plus 2y equals 180 minus 300 is negative 120. Bring the 5z over. And then divide everything by 2. We get y equals negative 60 plus 2.5z. And leaves us with z for that. Now, we can't have negative things, so there is a little bit of a limit. So if we think about this, if we take these, 100 minus 2z has to be greater than 0. We can't have nothing if we're making a mixture. So if we bring the 100 over, we get negative 2z is greater than negative 100. Divide by 100, z is less than 50. And then if we solve the other one, negative 60 plus 2.5z has to be greater than 0. 2.5z has to be greater than 60. Z has to be greater than 24. So for this to work, we also have to change our domain for z from 24 to 50. It's the only way this will work, because if we have less than that, oops, something disappeared. If we have less than those numbers, then we're missing one of the ingredients we need. So there's that. This just kind of shows that out, where they came from. All right, and then the last thing we're going to do is find the equation of a parabola that passes through these points. So we know a parabola is an equation like this. So it's the ax squared plus bx plus c. So we're going to plug those in for x and y. So y equals a and then x squared plus bx plus c. So if I rewrite that, we have 4 equals 4a plus 2b plus c. So that's the first one. The second one, we have 1 equals, and then we plug -1 in for x. So we get 1 equals a minus b plus c. And then the last one, 5 equals a times -2 squared plus b times -2 plus c. So 5 equals 4a minus 2b plus c. So now we have those equations. So all we did, we know they're quadratics, so we plugged them into the standard form of a quadratic equation with the x and y's. Now we're going to solve for a, b, and c. So if we combine these two, the c's go away. 4 minus 1 is 3. 4 minus 1 is 3. And 2 minus -1 is 3. 1 minus 5 is -4. 1 minus 4 is -3. And -1 minus 2 is 1. So now we have these. If we can get rid of the a's. So 3 plus -4 is -1. The a's cancel, and 3 plus 1 is 4. So 1 equals 4b. Divide both sides by 4. -1/4 equals b. So now we have our b. So let's plug that in. So we're doing the same thing we've been doing here. -4 plus equals -3a plus -1/4. Add 1/4 to both sides, we get -3.75 equals -3a. Divide by 3, a equals 1.25. So now we have our a. Plug those back into, I would do this one as the least coefficients. So 1 equals 1.25 minus -1/4 plus c. Solve that out. 1 equals 1.5 plus c. So we'd have, is that right? 1.25? 1.25 minus -0.25. 1 minus 1.5. Gives us -0.5 for c. So now we have our a, b, and c, which makes our equation y equals a is 1.25, b is -0.25, and c is -0.5. So that equation should work for all 3 points because we use them for our x and y's. So those are a bunch of different ways to use your systems. That's 7.2. Let me know if you have any questions.